Controlling for threats to internal validity in quasi experiments. This lecture actually also assumes that you have a strong understanding of the threats to internal validity and at least introductory level quasi experimental studies. Quasi-experimental studies are called a couple of names. Sometimes you see them being called time series, and other times they're being referred to as non-equivalent comparison groups. Um, I'll be talking today more on this lecture, actually, more on how a time series are being applied. In time series, we just have two phases, the baseline phase and the intervention phase. The intervention phase occurs after the application of an intervention, but all of these points at different points in time. So time one, time two, three, four, five, six. And that's what a time series look like. We have a simple time series. In simple time series design, what you see is a simple descriptions of different points in time. So just one treatment group, no control group. So the primary difference between the simple time series and a multiple time series is that the simple time series has just one treatment group being looked at different points in time without a controlled groups. So one treatment group. And let me show you how it applies. Now look at this table. We have patterns A, B, C, D, and we have different points in time from 95 all the way to 2004, and we have the intervention applied here between 99 and 2000, right here. Now, if you look, come look at A with me. In A, we see what's going on here. Of course, 1400 drops to 1300, drops to 1200, drops to 1100, drops to 1000. Intervention is applied, it keeps dropping 900, 850, 800, like that, keeps dropping down. One of the things you would say very strongly is that there was a pattern of decline prior to intervention, and even after the intervention, the decline continued in the same pattern. So I can confidently say that this is not necessarily, this decline here is not necessarily due to the application of the intervention. It looks more like, what we call the passage of time, or when people tell you things like, oh, just give it time, just time will tell. This is the kind of situation where the time will tell. In scientific methodology terms, we talk about the passage of time or maturation. So this is a clear case of maturation. In pattern B, we see, so from 900, we drop, it's 90, we go up 910, we drop 900, we go up 1,000, intervention applied, drop, go up, drop, go up, drop. So the whole drop, go up, drop, go up, drop, go up, drop signifies a pattern of regression to the mean. If you notice, the time series is just trying to regress to the mean, despite what's happening ups and downs, but it's still regressing. So this is not as a result of the application of the intervention. This is a situation of regression to the mean. Now let's see pattern C. In pattern C, we have 900, 1100, so it goes up to 1100, comes down 910, comes down again, then goes up, intervention applied, it comes down, good, you think it's good, and then it comes down again, okay, but then it goes up, comes down. It's just all over the place. The fact that there is no pattern whatsoever, the absence of a pattern is synonymous, or can be said to be the presence of an extraneous effect, which explains history, or history as a threat to internal validity. So history is more like what's going on here, not the intervention being applied. And then if you look at D with me, we see 1,000, so it goes up, comes down, goes up, comes down, but they're still approximately on the same phase between, not too far from each other, and then intervention is applied. The moment intervention is applied, see what happens here. Everything starts to go down all of a sudden, regardless of what was happening before the intervention. Now, sounds a little bit more plausible as to have happened as a result of the intervention. And these are all, of course, again, all simple time series designs. Now let's go to the multiple time series designs. I said it before that in the multiple time series design, we have the treatment group and the control group. So we're combining the time series concept with the concept of treatment and or control. So we have two of them. Of course, intervention is applied only in the treatment group and the control group gets nothing. Let's see this example. So assuming we pick the pattern D from the simple time series, and then we bring it here and we, look at it here, but then we're comparing, that's the one we said was plausible, that, at least was a little bit more plausible. We bring it here because so somebody can still look at it and be like, no, even though you think it's plausible because, after the application of the intervention, things seem to have declined drastically. There is still a possibility that history, at least there's an iota of possibility that history might have been the cause of this decline or this whole pattern. The way to answer that question, or to make sure that you eliminate every doubt whatsoever about what's the cause of this decline, is to compare it in a multiple time series design. So think of Wisconsin and Minnesota. Geographically, they are close to each other geographically. So if an extraneous effect, also known as history, is happening in Wisconsin, we expect it to also happen in Minnesota. So check it out. These patterns, of course, is similar here before the intervention. Once the intervention is applied in Wisconsin, we see a drastic decline. But in Minnesota, we see consistency exactly the way it was before the intervention. To me, it sounds like this is not history at all. Like this was the intervention. However, some people can still push and be like, well, are you sure? How can you say that? At this point, well, what would you do? There's still something to do anyway. We do what I talked about in the other video. We talked about switching replication. So we can switch and replicate, switch this intervention and bring it down to the control group. So pre-test, post-test, pre-test, post-test, apply intervention on the post-test of Minnesota. And if you get exactly the same outcome as you got in Wisconsin, then you can confidently say that the intervention was the sole reason for the result and nothing else. So internal validity is oftentimes talked as the extent to which a researcher can confidently say that the independent variable and only the independent variable, which is otherwise known as the intervention, causes the dependent variable, which is the effect or the outcome. So cause and effect. And that's multiple time series for you. Yeah, if this video was helpful to you, I would want to invite you to subscribe to my channel, turn on notification, feel free to share with a friend, and catch me every time I post something. Thank you.